Okay, in this video we're going to study some quadratics again, and this time we're still going to be using the calculator on occasion, but we are looking at quadratics once again. Okay, so let's look at the first one. We got a picture of a graph and it says the height versus the time. It's always important to look at the labels here. The time is on the x-axis, but they don't call it x this time, they call it the t-axis. So let's see if we can zoom in on this just a little bit. Okay, you can see over here that this is t. Okay, let's try that again. The t-axis, and that's also the x-axis, and this is my height. Alright, so if you remember, we used these words before, Dixie and Roy. Not that it matters so much on this problem, but nice to review. The D stands for domain, and the I is the input. X is because it's on the x-axis. And the last I is independent, and the Roy is range, the output of the function. So that's the answer you get when you look at your calculator in the table for the y's. It is the y value, and it depends. So the answer depends on what you input. So Roy is being told by Dixie what its value is. So it says that you drop it from a height of 250 and it fell to the ground. So you can, if you trace along this graph, you can see that it goes down here and then it hits the ground at 0, right? You start off at 250 and you go down, down, down till you hit the ground. Okay, so according to the graph, which time interval, which just means which period of time between two times, is the object at 140 meters above the ground? Alright, so we look up here at our graph and we have 0, 30 feet, 60 feet, 90 feet, 120, and 150. So if we just sort of take and on our paper just sort of draw a line where about where 140 might be, okay, and it looks like it hits the curve right there, and then I'm going to draw a line straight down and hit the t-axis, and it looks like it's somewhere there like 3.5 seconds, right, in between 3 and 4. Okay, alright, so we have to get a little more precise because look how close these seconds are. Okay, what is between 3 and 3.25? That's the smallest interval, right? 3 seconds and 3.25. Let's see if we can get a little closer. Between 3 and 3.25 would be this first interval right here, so it's not quite high enough there, so I'm going to eliminate that one. And let's go look at between the next one, 3.75 and 4. That's way over here, right? Way over here. At 4 seconds, it's way too low, right? So I'm going to cross that one out. And between 3.5 and 3.75, so there's 1, 2, 3, 4 marks in between. So 3.5 would be the second mark, right? And that looks like it's probably going to be it. So even if we just had to guess, we could pick between H and J, because those are pretty close to each other. I think we're going to go with H on this one. Okay. All right. Let's take a look at the next problem, because here we're going to use the calculator to solve this one. It says, which of the following vertex of the graph y equals 3x squared minus 8x plus 4? Well, we don't have a picture to look at, so let's get our calculator out and see if we can solve this one. Now, how big is your window here on your x-axis here? Just look at the picture here. It goes from 0 at the origin all the way out to 10 seconds. And the y goes from 0 all the way up to 10 seconds here, right? And it goes to negative 10 over here. And negative 10 down here, right? So if you remember from the previous videos, if we do a zoom number 6, that'll give us our window that's 10 wide. So let's go ahead and turn our calculator back on, and let's clear this out. We had some equation in there from before. We had another equation here, and let's go back up and let's see if we can find our vertex. So type it in exactly like you see it: 3x squared minus 8x's and plus 4. Alright, and let's do our zoom 6 to make sure that we're on the right spot here, and you can see the graph being drawn up. Okay, so let me see if I can drag this over here and copy it. Let's try that again. And it's being dragged somewhere. Let me go see if I can find it. Way down here. I'm having a little difficulty getting it moved over there. Let's see. Well, I'll just do it right here. I'm going to delete that one, delete that one. Alright, so let's make this bigger here. Alright, so I can draw on this. Remember, there's a couple of interesting things about a quadratic. One is where it crosses the x-axis, and it happens twice right here. And these are called the roots, and they're also known as the zeros, and they're also called the solutions most of the time. But it's not asking us for the solution this time, it's asking us for the vertex. So the vertex is where something changes direction, okay? And in this case, the vertex changes direction. Think about it like a roller coaster. You're sliding down the roller coaster, and then you hit the bottom of the hill right there. So in this case, our vertex is also called minimum value, okay? The minimum value. And if it's an upside down parabola or quadratic, it'll be a maximum. But anyway, we just need to go figure out where that is on the calculator, all right? So let's go back up to the problem here and get the calculator back on. And we're going to use the trace button here. So remember, the top row here is your graph features. So hit the trace button, and you can kind of roll your mouse down here, and you can write down these numbers if you like. It looks like it happens at about 1.48. 1.48, which is 1.5. Okay, well, we want to get exactly on that vertex, so we're going to use the trace button still, but this time we're going to type in our values, our x values. Okay, so let me see if I can draw on this again. So what we're going to do is we're going to type in x equals 4/3. We're going to use x equals 1/2, x equals 0, which we know isn't the answer, and we're going to try x equals 2/3, and we're going to see which one gets us closest to that minimum point on our graph. So let's go back here and get our calculator going again. I hit trace, and I'm going to type in 4/3. 4 divided by 3, and hit enter. And it looks like it's pretty darn close to the vertex, right? See how the spider went right to the minimum point? It's probably going to be my answer, but let's just try 1/2. So you're still on trace, hit 1/2, 1 divided by 2. See it down here, hit enter, and that's certainly not the bottom, right? X equals 0, hit enter. That's not the answer. And let's try 2/3 just to double check it. And when I hit 2/3, it's not at the bottom either. So we're pretty happy with the fact that we have answer choice A. Alright, let's go to the next problem here. Let's see if I can get rid of this. We don't need that anymore. And let me erase all this other business down here. Alright, it's all gone now. Okay, we have a graph here, and this time we have the picture of the graph, not just a blank one. And we don't have to type this equation in if we don't want to. So let's just look at it. It says, which point represents the vertex? Alright. Well, draw over your test if you need to. There's the vertex right there. And we're just going to go to our points and see which one's which. At negative 4, 0, that's a root, isn't it? That's not it. So I'm going to eliminate answer choice A. Alright. 2, 0 is this point here. That's another root. So those are my roots, and they're not asking us for our roots or a solution. 0, negative 8. If you start off at 0 and you go down 8, that's not the answer either, is it? 0, negative 8 would be coming down right about here, right? That's the y-intercept. And so by default it has to be the last one, which is negative 1, 9. Let's zoom in on that just so you can double check that. So you go over negative 1 and you go down to negative 9, and it puts you right there at the vertex. So that was our answer choice, and it is H. Okay. Alright, so I hope you had some success with this one. If you need to watch it again, rewind it and watch it some more.